All right, so if we had something that was log, I don't know, base 7 of 2x, okay? And I wanted you to expand it, what would that turn into?
Log 7.
Log 7,
Log 2.
2
Log 7 2 plus log 7 x.
plus log 7x. So they get separated, right? With a plus sign in the middle. Can you please stop? Thank you. All right, with the plus sign in between them is what's going to happen. That's our expanding. To condense, we would multiply going backwards, right? Next, quotient. Okay, so if I gave it to you, let's say 2 over x, like that. How would I separate them? No, we're just reviewing together. So does the 2 or the x come first, or does it matter?
2 comes first.
The 2 has to come first because it's my numerator. And then what goes in between them?
Negative.
The minus sign. All right, power property. So let's say it was log 7 of x squared. What are we going to do with the power?
You're going to...
Yeah, 2 log 7x. We move it to the front. Okay. And then the last one we did was the identity property. This is the one that y'all liked because it canceled things out, which we're going to use when we solve today, right? If we're solving logs, I don't want logs in my answer anymore. I need to figure out what to use to get rid of them. So if I have a log, we'll keep it 7 squared, like that. The bases touching each other, run away together. Oh, and we're left with just, I got ahead of myself. We're left with just 2. Okay? Vice versa, if I already have a base of 7 and it's raised to another log with the base 7 of x, 7 log 7 cancels out, we're left with just x. Okay, so this is a quick little review of all the properties we've done, and we're going to keep using all of them. Some of you knew them Friday, some of you did not know them Friday. So we need to know them. We're still going to use them, okay? Especially when it comes to our unit test on Friday. It's all coming together. And even with natural log, the properties are the exact same thing. Properties won't change. We just have a different log to work with and a different base. All right, sneak peek. The base is E. True story. You'll have to wait and see what that means. Okay, let's start solving. Okay, to solve a log, you have to use the properties of logarithms to condense into a single log, then bring in matching bases to cancel out the logarithm, and then we can solve. Okay, here's a special note. Sometimes it's a little bit easier than all that. If we have a log equals to another log of the same base, then we can just say that x equals y. Their values equal each other. So like here, log 7x equals log 7,5. I can just say, oh, well then x equals 5. So if we spot that along the way, use it, okay? And the problem comes a little bit easier. It does not always happen, though. I have an example worked out completely for you on the left, and then we'll do one together on the right. So on the left, I have log 2x plus log 2,3 equals 5. The first thing I had to do was condense them, and what property was used to condense them? Which property was that? Our product property, yes. Which meant we do multiply them together. So log 2 of 3x equals 5. Then it says bring a base to both sides. What base did we bring? A 2, right? And where did that 2 come from? Yeah, the small thing on the log. That tells you what you need to bring in. My log has a base of 2, so I need to bring in a log with a base 2. Okay, doing that cancels out my logs on the one side. We're left with 3x. Over here, 2 to the 5th is 32. It's not 2 times 5. It's not 10. It's 2 times 2 times 2 times 2 times 2 is 32. Then our last step here is just to divide by 3 to solve for x, and we just get the 10.67. Okay? Yes, properties are essential. So my other side, log 4 of 100 minus log 4 of x plus 1 equals 1. We have to condense first. You cannot jump into bringing bases. I know you really want to, but you cannot. You have to condense first. Okay? So, how am I going to bring these together?
Log 4 of 100 over x plus 1.
Okay, so you're doing the quotient property, you're dividing. Okay? And it's equal to 1.
And then you bring out that 4.
So I'm not bringing out a 4. Be careful with your verbiage. You have to bring in a base of 4. Okay, I'm going to show you a cool little trick. I'm just going to draw the 4 on each side like that. So my green equation is now an exponent. All of the green has been lifted up to an exponent because I gave each side a base of 4. So all the green has lifted up. 4 log 4 cancels. We're left with 100 over x plus 1 is equal to 4 to the power of 1 is 4.
Makes sense.
You say that now, but you're going to try to multiply later. Don't do it. Don't do it. Someone always does. All right, how do we get rid of fraction?
You have this whole
Multiply by what? Or the denominator. Get rid of those guys. Now I have 100 equals what? 4x plus 4? Now what do we do? And then, which is 24. Oh, I shouldn't have circled that yet. Hold on, we should always check my answers. Before I circle it, we should check it first. What I'm checking is when I plug it back into my logs, I can't have a log of a negative number. Okay? You can never have a log of a negative anything. Okay? That can never, ever, ever happen. That does not mean that if my answer is negative, the whole thing's going to be wrong. It's all about plugging it back in. So if I plug it back in into x plus 1, is 24 plus 1 still positive? Yes. So this one is fine. Okay? Some of the ones you're going to see on your homework, when you plug it back in, you get a negative right there,
and that's wrong.
and you can't do it. It's called an extraneous solution. Fun word.
Oh, so it's not necessarily wrong, you just need no solution.
It's an extraneous solution. It's not going to work. That logarithm would not touch the x-axis at that point. Okay, questions? Let's do another one. Excuse me. Hiccups. It's Emily's fault, I'm sure. Just passed them on to me. All right, so 19a. We have log 3 of 2x plus log 3 of 7 equals 4. Can I go ahead and bring in a base of 3, start canceling out logs? No, you have to condense first. Have to. You will get it wrong if you do the base first. Okay? You have to bring these together. How are we going to bring these two together?
Log 3 of 2x times 7.
So we're going to multiply them together to give me 14x. Yep, equals 4. Now can you bring in the base? Yes, now we can bring in my base. Because it's all about that base. About that base. About that base. Yes, I did. You're welcome. My base is 3. So 3 log 3 cancels. We're left with 14x. It does not equal 12. Because 3 raised up to the power of 4 is 81. Very different from 12. Do not multiply. You're bringing in a base. All right? From here, I'm going to divide. You will get a fraction, and that's okay. 5.8-ish. Okay? Before I circle, let me double check. Okay. So I have log 3 of 2x. I got to make sure 2x doesn't give me a negative number. Is 2 times 5.8 negative? No, so we're fine. I don't even care what the number is. I just care negative or not negative. All right? So that one would work out. All right, my middle one. Remember, you love me. Okay, just remember. Just remember, we're friends. Before I do this next one.
Oh my
It's not too bad.
Because, remember, you love me. It's fine.
That's x squared plus
It's not going anywhere. Yes, factoring is always a thing. All right. Kaylee is enraged. Are you done? You give up? All right. Log 12 of x plus log 12 of x plus 1 equals 1. What product will I use to condense them first? We will do the product, so we'll multiply. So what is x times x plus 1?
X squared plus x.
Yes.
That's not too bad.
It's not. Okay. What base are we going to bring into both sides? A 12. Good. Base of 12, so that cancels. We have x squared plus x equals, what's 12 to the power of 1? 12. There is an x squared. We are going to have to factor. So let's make this equal to 0 first by moving my 12 over. Oh, you're fine. Come on, kids. What multiplies to give me negative 12 but adds to give me 1?
Negative 4 and 3. Negative
How about a positive 4 and a negative 3? You were thinking of the answers, right?
Yeah.
4 times negative 3 is negative 12. 4 minus 3 is positive 1. You can do this. So we get x equals negative 4 and x equals 3. Again, before I circle anything, I need to check them both. Log 12 of x. Can I plug in negative 4 right there?
No.
Nope. Can I plug in a 3 right there?
Yes.
Yeah? Okay, so we already know negative 4 is out. Negative 3, though, has to work for both of them. Will it work right here? Is 3 plus 1 still a positive number? Yes. So 3 is my only answer.
So negative 4 is extraneous, but
Negative 4 is an extraneous solution. Yes. Well, wasn't that bad, right, Kaylee?
she's not.
I know, she's not talking to me anymore. Silent treatment. All right, last one before I let you work on these last 3 on your own. All right, this last one has 2 properties, right?
Yeah.
Which ones do you see? Quotient and
Power.
quotient and power. Always do the power one first before you start dividing, okay? So we're going to pop this 2 back up.
Yeah, that x comes in front.
So it's x squared minus log 4, okay? Then we can do the division. So it becomes log x squared over 4 equals 0. I did the quotient property.
Oh, I thought you did the power property first.
I did. The 2 went up to the x. That was the first part. Okay. Why? Where did 10 come from? I don't see a 10. What is this called?
Common law.
Common law. Good. Base of 10 to both sides, so that one is gone now. We have x squared over 4 is equal to 1. Beautiful. How do I undo a fraction? What do we do? Multiply by the denominator. I get x squared equals 4. How do I undo a square? Square root. We get x equals 2 and, good, negative 2. Don't circle until you check. Okay? Could any of them not get plugged back in?
Negative 2.
Negative 2, right here. 2 log x, that x cannot be a negative. Wah, wah. So the only one we're going to circle is a positive 2. Okay? I would like you and your friends to try number 20, all 3 of them. Okay, you can do it. You will get whole numbers. You will get whole numbers for all 3 of the bottom ones.
I can't see 2, 3.
All right, check your answers with mine.
4, 5.
Check your answers with mine.
Wait, how do you do C?
Yeah, I just need help with C.
Just C? Okay, I can help you see. Real quick, before I do C on part B, why did I cross out the negative 6? Can't plug it back in, because look, negative 6 plus 9. Hey, listen. Negative 6 plus 9 is positive 3, though. that would still work. The problem is over here, where it has log x to each other. This is where the -6 would not work. Okay, so make sure you do check both pieces, because if you only checked this piece, so the x plus 9, like, oh yeah, it works. It doesn't. All right. Okay, so we need to see. So it becomes x. Hold on. We have to do our power property first. So bring that up. Then we're going to multiply. So it becomes log 8x cubed equals 3. What are you talking about?
For B, yours says x plus 9.
Yeah.
Yeah,
Oh,
But she was talking, I was confused.
interesting. Okay, this right here says plus 3.
Yeah.
No one has told me that all day today. Boop.
Why were your favorite?
But you still get 3 and -6, right? And -6 still doesn't work. Okay. You are all my babies. All right, from here, it's a common log. You bring in a base of 10.
Oh, because that's the numbers.
Uh-huh. So now I have 8x cubed. It does not equal 30. Some of you put it. It's not right.
No, it's
10 times 10 times 10. Yes, it is 1,000. That is an exponent. You know tens and exponents, their exponents tell you how many zeros it has? Fun fact. 10 to the 7th power is a 1 with 7 zeros. True story.
8x is equal to 3.
No, then it's x cubed.
8x is equal to, wait.
It's x cubed is equal to 125.
Oh, yeah.
Then you cube root to get the 5.
Oh.
Like that.
Wait, so you don't cube it first?
You can't. It's not by itself. You can't cube or square root unless the x and the power is the only thing there. Questions? Thank you.
Oh, okay.